Okay, let us begin. These are some of your questions. I don't know if you have seen them. So we're going to be taking them one after the other. So as the case may be. So let's start with the first question. I don't know if you can see. If you can see, please indicate. Let's start with the first question here. So you are free to let me know if you have seen the question. So we can be taking them one after the other, starting from question 1. That's a force that acts on a mass of 1 gram gives it an acceleration of 1 centimeter per second square is defined as what? So let me know if you are saying this so we can answer them. So this question 1 is all about SI units. We have the basic SI unit, which is mass in kilogram, length in meters, time in seconds. Those are the basic SI units, also known as the fundamental unit in physics. They also have CGS, which is centimeter, grams, and seconds. So if you look at this question here, it falls under CGS, centimeter, grams, and seconds. So as you know, from Newton's second law of motion, says that force is equals to ma, which is mass times acceleration. So what happens if we are dealing with grams and centimeter per second square? So it won't give us Newton, because it's kilogram meter per second square that will give us Newton as a unit of force. Please, you can speak up if you are hearing what I'm saying. Unmute and speak.
Recording in progress.
You can hear me, please speak up.
Okay, for you to talk, you need to unmute your microphone.
To speak, you need to unmute. The microphone is closer to you there. Unmute and speak so that we can commence, please. can hear you. Can you hear me? So, welcome all of you. So today we are looking at your Physics 101, and it happens to be Mechanics and Properties of Matter. It's a 3-unit course. So I'm going to start from question 1. I don't know if you have seen the question. If you do, I would like you to speak up. Thank you very much. Thank you. So, question 1, let's read it. Let's do it quickly. And if you have any area that is not clear to you, feel free to ask questions. So, let's see. So, let's see what the question says. Question 1. It says, force that acts on a mass of 1 gram gives an acceleration of centimeter. So that place, there's a typing error there. It ought to be centimeter per second square, not centimeter minus 2. It's supposed to be centimeter per second square. Is that unit of acceleration? It's defined as what? Now, this question is all about SI units and the concept of force. We all know from Newton's second law of motion that force is ME, which is mass times acceleration. That is the formula of calculating force. Mass times acceleration. So, but to understand this, you need to understand the basic concept of SI units. So SI units, they have two types. We have the basic SI unit, which is mass, kilograms, and meter. We also have GCS or CGS, which is centimeter, grams, and seconds. So if you look at the data given to us here, they gave us the mass in gram and the acceleration as centimeter per second square. So which fall under CGS, centimeter, grams, and seconds. So let's try to impute the formula of force we stated earlier as MA, mass times acceleration. So as you know, force we know is MA, mass times acceleration. So, but if the unit of mass is kilogram and acceleration is meter per second square, this will give us 1 Newton as force, which fall under the basic SI units: kilograms, meters, and seconds. So in that case, you are having a Newton as a unit. But what happens if my mass is in grams and acceleration is centimeter per second square? So there's no way it will also give us a Newton. No, because the units are not differed. Although they are interconvertible, you can convert them from one to another. So in this case, my force here become dyne. It's no longer Newton. It will give us 1 dyne. So the answer to that question is dyne when you are dealing with grams, centimeter, and second square. But if you are dealing with kilogram, meter per second square, what you have is Newton. So the answer to this question is dyne as unit of force when you are dealing with grams, centimeter, and seconds square. So those are the two concepts of SI units, just in case. So that's the answer to question 1. So let's go to, I don't know if it's clear, let's go to question 2. So the answer to question 1 is B, 1 dyne. Because, so let's move to question 2. It says an object moving in a circle of radius r with a constant velocity v has a constant acceleration towards the center equals to what? So let's draw a diagram to illustrate what they are saying. So this is a circle now. Every circle has a center. From the center, I call it center O, from the center to any point on the circle is radius. So this body moves with a constant velocity v, which is tangential to the circle velocity v. So the force I will keep an object towards the center of the circle, we call that the centripetal force. And from the concept of centripetal force, Ft, which stands for centripetal force, the formula is mv squared over r. That's the formula of centripetal force. From the question 1 we just did, we are told that force on its own, from Newton's second law of motion, is ma. So if I should fix force in place of force, in this place as it is, and we are still force, I will put ma. So I'm having ma is equals to mv squared over r. So you agree with me that m will cancel m. So we are left with a now is simply v squared over r. So this is the value for the centripetal acceleration. That is the value for the centripetal acceleration, which happens to fall in question. That happens to be in question option B, v square over r. So the answer to that question is A. Question 2 is also A. Question 1 is B. Question 2 is A. So if you are following, then that goes to question 3. Say the dimension of strain are what? They gave us some basic option A is L, option B is ML minus 1, option C is L minus 1, option D is a dimensionless constant. How so? So for us to understand the concept of dimension, you must know the definition of each quantity you are given. Knowing the definition will go a long way to save you. So let's see what we have here. Strain. From elasticity, strain is defined as extension, the ratio of extension to original length. That is the formula of strain, the ratio of extension to the original length. So in symbols, strain equals to E over RO. That is the formula of calculated strain. So from this formula now you can determine the dimension of strain. So extension is measured in meters, while original length is also measured in meters. So the point is, extension is in meter, while original length is also in meters. So you agree with me, meter will cancel meter. That means strain is dimensionless. It has no dimension. So if you go back, that happens to be question D. It is a dimensionless quantity. You can see from what we've done, meter cancel meter, strain has no SI units. It has no SI units. So question 3 is option D. So let's go to question 4. It says due to the energy dissipation by a viscous force in air, if a simple harmonic of a pendulum dies away after some time, then the oscillation is what? We actually call it damp oscillation. The word air is referred to as fluid. Air and liquid are called fluid. So the viscous force can only take place in fluid, such as air or liquid. So that viscous force is also called a drag force. It's defined as the resistance offered by a liquid to flow. That is the definition of a viscous force. It's the resistance offered by a liquid to flow. It's referred to as a viscous force. So from this question, so the oscillation is called a damp oscillation. Why is it so? Because the drag force, also known as viscous force, acts as a damping force. So this damping force is in the sense that it will convert mechanical energy as heat. You convert mechanical energy as heat, and this will make the amplitude to decrease exponentially. The amplitude is maximum displacement from the equilibrium position. So when you damp a simple pendulum on a viscous force, the amplitude will decrease because the viscous force, which is the drag force, it will reduce the rate of oscillation of the pendulum. So the answer to that is damp. Question 5 said, when work done is moving a particle around a closed loop in a field is 0. Force in the fields are called what? They are conservative. They are conservative force. For something to be conservative, that means there is no loss of any form of energy or heat. There's no loss of any form of energy or heat. So that means it takes place in a closed system. For something to be conserved, meaning it takes place in a closed system. Nothing is lost. So when nothing is lost, we call such a system a closed system or a conservative system. So since the work in the closed loop in the field is 0, then we can say that system is conservative. So number 6, say the dimension for relative density is what? Relative density is, as you know, is the density of an object to equal volume of water. That is the definition of relative density. Density of an object to equal volume of water. So for relative density, there's no unit. Although you can convert it to density on its own, there's a difference between density and relative density. Density is measured in density, as you know it. Density is simply mass over volume. So in the concept of dimension, my mass is capital L, volume is L raised to power 3. So if you apply the law of indices, density will give you m minus 3, which is kilogram meter cube per meter cube. That's the unit of density. But in this case, we are dealing with relative density, which is density of an object to equal volume of water. For relative density, it has no dimension or unit. It has no dimension or unit for a relative density. So let's go to the next question, which is question 7. The dimension of gravitational constants are what? The dimension of gravitational constants and what? So let's see what the dimension of gravitational constants will be. From Newton's law of universal gravitation, it states that F is G m1 m2 over r squared. This is what Newton's law of universal gravitation states. So if I make the G the subject formula, which is what we are looking for, let me make the G the subject formula. So my G from here will give me F r squared over m1 m2. So what's the dimension for force? Force on its own is m lt minus 2. That dimension for force. Then radius is L, while mass is capital M. So these are their respective dimensions. So if you should fix them wherever we see them, in place of force, I will put this to represent force, I'll put it to represent radius, I'll put this to represent mass. So if you should fix them into the expression, my G will give me m lt minus 2 times L squared, which is for the radius, over m times m, which are the two masses. So I can apply the law of indices to these two L here because they are multiplying each other, and the power this L have is 1. Every object is raised to power 1. If I apply the law of indices to these two, my G will give me m L1 plus 2 t minus 2 over m squared, which is m times m. And this m here is raised to power 1 also. So I can apply the law of indices to these two m. The law of division in indices. So if I should apply that, I'm going to have m 1 minus 2 L raised to power 3 t minus 2. If I simplify, it will give me m minus 1 L raised to power 3 t minus 2. So this is the dimension for gravitational constant G. So let's check what the answer could be. The answer is A. M minus 1 L raised to power 3 t raised to power minus 2. That is option A for number 7. Then number 8, we have a person of mass m kilogram jumps from a height h meter a land on the ground with a velocity equal to what? So this is the concept of conservation of energy. For energy to be conserved, it means there's no loss of energy. That means, in this case, the kinetic energy is equivalent to the potential energy. That's the only way energy can be conserved. Your KE is equal to your PE. So if KE is equals to PE, that is kinetic energy equals to potential energy. And we know the formula of kinetic energy is half mv squared. Formula of potential energy is what? mgh. So why is this so? We have a conserved energy. Energy is conserved. We have a conserved energy. So what happened? This mass can cancel this mass. I'm left with half v squared is equals to gh. So for me to find velocity now, which is what you're asking for, I will cross multiply by breaking 2 to meet these guys. So my v squared will give me 2gh. So my v simply was the square root of 2gh. That's not the expression for the velocity. So if you check your option, it's 2 times g times h, which happens to be option A. If you have any questions so far, you are very free to ask. Any? Okay. But in the absence of none, we continue. Now I say in a linear motion, energy is given by half mv squared, which is kinetic energy. Similarly, a rotational motion, rotational energy is given by what? Now, if you go to question 2, we've done something similar to question 2 is all about rotational energy. It's a combination of, this question 9 is a combination of linear energy and the rotational energy. So let's see how we answer that question. Okay. Ofimai, you raise your hand, you can ask question. Go ahead and ask. Oh, number 8, okay. Number 6. Okay, go ahead. What's that? Okay, that number 6. Okay, let me repeat it. So here they are asking of relative density. Now, the concept of dimension is this. For you to understand the dimension of anything, of any physical quantity, you must first of all know the definition of that physical quantity. So in this question 6, they are asking of relative density. What is relative density? Relative density is also called specific gravity. That is the other name for it. It's called specific gravity. And by definition, it's the density of a substance divided by the density of the reference substance, or the density of a reference substance, or the mass of the substance divided by the mass of equal volume of water. That is the formula of relative density. Density of the substance over relative density now is density of a substance. Density of a substance divided by reference density. That is the formula of relative density. Now, what is the unit of density? Density is defined as mass per unit volume. That means it's measured in what? Kilogram per meter cube. Divide by, then the reference substance is also density. It's also what? Kilogram per meter cube. So since both of them are the same, what will happen? They will easily excuse themselves. So you can see we are left with nothing here, which is dimensionless. So relative density or specific gravity is dimensionless. So that is why we choose option C. It has no dimensions. It's the ratio. It's a ratio of two densities. That's why we pick option C. So Aisha, you can go ahead and ask your question. Evening. Okay. I say due to the energy dissipations by viscous forces in air, if a simple harmonic of a pendulum dies away after some time, then the oscillation is said to be what? So I told you the answer is damped. Now let me explain to you. You know a simple pendulum now. This is how it is. This is the pendulum bob and the thread. So when you oscillate it, it will move to and fro like this. There is an angle here. Okay. So if you are oscillating this with a resistance force, the viscous force is also called a resistance force. So the resistance force will alter the rate at which these objects oscillate to and fro. It will affect the rate it oscillates. So because they call it drag force or viscous force. Viscous force is also called drag force or a resistance force. So when the resistance force is acting against a system, the rate of oscillation will decrease with time. If we decrease the time, such process, we call it damped. When oscillation decreases with time, we call it damped. But if the oscillation did not decrease, even after an external force out of the system, we call it undamped oscillation. So damped oscillation means it's affected by a viscous force. A viscous force is also called a resistance force. So that is what I meant. So air will be acting against this system. Air will be acting against it. So when air acts against it, it will reduce the rate of oscillation. By reducing the rate of oscillation, the oscillation will die off with time. That process we call damping. Is it clear? Okay. All right, you're welcome. So let's go to question 9. Here you say in a linear motion, energy is given by half mv squared. So that is a linear motion. We're talking about kinetic energy here. So similarly, in a rotation, so how do we relate linear to rotational motion? How do we relate the two? So this question now is asking you to relate linear motion to rotational motion. So if you look at your expression, we have the options. Where H is called moment of inertia. H is called moment of inertia. So what is the relationship between linear motion and rotational motion? So let's try to establish the relationship and see what the answer could be. So let's quote the formula of kinetic energy given to us from the question. Our kinetic energy, which is the linear motion, is equals to half mv squared. That is kinetic energy. What about moment of inertia? Moment of inertia is I is m r squared. That is formula for moment of inertia. Mass times the radius square. Okay? So we are also told that V is equals to angular radius. Relationship between linear velocity and angular velocity. Linear velocity is the V, while the angular velocity is our omega, which is this symbol. This is our angular velocity. The relationship between them is angular radius. So if I substitute V in place of this V now, let's put V in place of this V. We are going to have KE now as half m. So in place of V, I'm putting angular radius or squared. So if the square here is governing both the angular velocity and the radius, the square should affect both of them. What are we having? Half m angular square radius square. I believe we agree with this. If this question have fed both of them, I'm going to have angular square, radius square. But don't forget, we stated what moment of inertia stands for. Is m arrow square. If you look at these two expressions, it cover for them. We are having m arrow square as our moment of inertia. Therefore, the kinetic energy becomes half angular square I, where I is called moment of inertia. That is the mathematical expression for the solution. So what are we having there is half. Let me go back to the option. Is half angular square I. So the I here is also called h. From what they have done there, the I is also h. So we're having half angular square h, which is option C. Half angular square h. Although moment of inertia is actually I, not h, just in case. Although they represented it here as h. You see where h is moment of inertia, but the ID symbol is I. So that would leave us with option C. Is half. That's what we got. Is half angular square h. From what they have, half angular square and h. That's the expression. So this is how you relate moment of inertia, linear velocity, and rotational velocity or angular velocity. That's the mathematical expression or the relationship between both of them. So let's go to question 10. So the following are instruments used for measuring length of the substance except we have a caliper, micrometer, screw gauge, we have beaker, we have vernier caliper. A beaker, we use it to measure volume. I believe you know beaker in chemistry. Which is one you use in titration. We cannot use to measure length but volume. So the answer is C, is beaker. Caliper, we can use to measure both diameter and length from blind holes. What we call blind hole, like a test tube. The depth of a test tube, you cannot measure it with a ruler. The only way you can measure it is through caliper. And that depth of a test tube, we call it a blind hole. Because we don't actually know the depth. By looking at it does not mean you know the depth. For you to actually know the depth, you have to use a vernier caliper to do it to measure the actual length of that test tube. So the answer to this question is C, a beaker. So the following are fundamental quantity except we have basic units or fundamental units, which are mass is fundamental. What are fundamental units? These are quantities that are independent. They don't depend on anything before they exist. Independent of other quantity, like mass. There's no doubt every object on this earth has a weight or mass. Whether we like it or not, the day must dark, the day must break. So it does not depend on anything before it happens. Whether we like it or not, every object has a particular length. So those are basic quantities. Like temperature is also a fundamental quantity. Whether we like it or not, the day must be cold or it must be hot. Like current is also a fundamental quantity. The water must flow. Whether we like it or not. Notice, so they don't depend on anything, any external factor before they exist. Such quantity we refer to them as fundamental quantities. So we have the options there. We have velocity. Velocity is derived. Why is it derived? Because it depends on distance and time. It depends on two things. Velocity depends on distance and time. For that reason, it's no longer fundamental, but a derived quantity. That is the answer for the question. Is A. The answer is velocity, because it depends on two things. Time does not depend on two things, like I explained earlier. The day must dark and day must break. It does not depend on us. It does not depend on anything. Mass does not depend on anything. If every object you hold, your water, your notebook, your biro, all of them has weight. Anything that has weight must have mass, because weight is mg, mass times gravity. So mass is also a fundamental. So the answer to that question is velocity, which is option A. Then question 12. He said, one of the difference between weight and mass. Like I said, weight is mg. Weight, from that reason, is a derived quantity, not fundamental. So that can be one of the difference between them. While mass is a fundamental quantity, because it does not depend on anything before it exists. Weight depends on gravity and mass to exist. So is that weight, then 2, weight is a vector quantity while mass is a scalar quantity. Also note that weight is measured in Newton, mass is measured in kilogram. Also note that. Then we have different instruments we can use to measure them. We can use a scale pan or a spring balance to measure weight also, although we can also use to measure mass. So that could not actually be a difference. So we can use their units, whether they are vector or scalar, to also differentiate them, and whether they are derived or also fundamental. So the answer, mass is a vector, which is false, while weight is a scalar. No, it ought to be the opposite. Weight is a vector, which is true, while mass is a scalar, which is also true. So the answer is option B. Number 13, unit that cannot be derived. This is what I was saying right now. Unit that cannot be derived from other units. This is what I'll just be explaining from question 11 and 12. Unit that cannot be derived from other units. As you know it, we call them fundamental units. While those you can derive from others, we call them derived units. So the answer to question 13 is simply A. You say 1 light year is equals to how many? 1 light year. What is a light year? 1 light year is equals to what? So let's know what a light year is. Can anybody tell us what a light year is? A light year is simply 1 year. That's the value of a light year is simply 1 year. So how do we convert 1 light year to meter? The answer, 1 light year is 9.46 times 10 to the power 18. That's the value of a light year. 9.46 times 10 to the power 18 meter. That's the value of a light year. Although the option is not there, so it ought to be 9.46 meters, not except maybe you want to convert from meter to mile. What's the relationship between meters and mile? Can anybody suggest relationship between meter and miles? 1 light year, like I said, is 9.46. Except you choose to convert meter to mile. 1 mile is 1,609 meters. That's the value of 1 mile. So if you convert it, if you divide by that value of 1 light year in meters, the answer might fall between option A. But 1 light year is 9.46 times 10 to the power of 18. That in meters. So this is our channel we are using is STEMupAfrica. It's our YouTube channel. We are trying to grow it. So if you have not subscribed, please help us to do so by assisting us so that we can grow our channel. Thank you. So let's see what question 15 says. It says if a force of 40 Newton is acting in direction of due east and direction. Okay, also that's the wrong typing. The force of 40 Newton is acting in the direction of due east, and 30 Newton is acting due north. So then the magnitude of the horizontal force, or the sum of the two forces, will be what? Let's illustrate it. As you know, in our cardinal point, this is our cardinal point. We have north, here is south, east, and west. So it says a force of 40 Newton is acting due east, meaning it's acting in this direction, eastern direction. So let's see. Let's take as our reference point. A force of 40 Newton is acting due east, while another force is acting due north. That one is 30 Newton. Acting due north. So they are not acting on for the horizontal force. According to parallelogram law of vector, say the horizontal force must come from the point of concurrency. Point of concurrency is the point where two or more forces leave or meet. So the horizontal force will come from here. The point of concurrency of the two forces. So I can also create a different line. This line and this line are parallel to each other. That means here is 30 Newton, here is also 30 Newton. You can see what we have here now is nothing but a what? A right angle triangle, of which the resultant force here is representing our hypotenuse. So if I consider it as my angle, that means the 30 Newton is representing the opposite, while the 40 Newton is representing the adjacent. So to find the hypotenuse now, which is the resultant force, I will apply Pythagoras theorem, which says that hypotenuse square is equals to opposite square plus adjacent square. So the opposite now is 30, while the adjacent is 40. So if I should apply that, I'm having arrow square now to be 30 square plus 40 square. And what is 30 square? That will give us 900. What is 40 square? That will give us 1,600. If we add up, what are we having? We should be having 2,500. That is now my arrow square. So what is our arrow? It's simply the square root of 2,500. And what is square root of 2,500? That will give us 50 Newton. Is the value of the resultant force is 50 Newton. So if you check your options, that happened to be option D, 50 Newton. Question 16 is similar to question 15. You say a cross-country skier skis 1.0 kilonewton north and then 2 Newton east to a horizontal snow field. How far and what is direction she is from the starting point? So the cross skier is first of all move north and then east. So it's similar to what we just did. So let's see. Let's take it as our reference point. He moved north. By moving from north, let me say here point A and point B. And he did that in 1 kilometer. So it's the girl is no longer at point A, it's now at point B. So on that point B, here is also north, here is south, here is east, and here is west at the cardinal point of B. So he said he didn't stop at B. Say then that's where he left point B to another point due east. Now he traveled due east now to another point, and he did that in 2 kilometers. And he did that in 2 kilometers. So they're not asking us. The girl now is at point C. Is currently at point C. How far is she now from the starting point? Say how far is she from the starting point? So we're expected to calculate the distance between A and C, or C and A. So here is our right angle. That means this figure also represents a right angle triangle. So the distance between A and C represents the hypotenuse, which is similar to what you just did. So I'm going to have AC square is equals to AB square plus BC square. So what's the value of AB now is 1. I'm having 1 square plus 2 square, which is 1 plus 4. 1 square is 1 and 2 square is 4. If you add up, that will give you us what? 5. What's that my AC? Give us the square root of 5. Square root of 5 should be around 2.23, if I'm not mistaken. That should be the square root of 5, 2.23. That is option, or let me say 2.24. That is option C. That's option C. So if you go to question 17, it said a vector that has a magnitude of 1 with no unit, its only purpose is to point dash, that is to describe a direction in space. So a vector with one, we call that a unit vector. When the value is 1, we refer to as a unit vector. It's called a unit vector. Where you have your value as 1, refer to as unit vector. Babe. So, can you shift and come and big? Okay. So the answer to question 17 is a unit vector. Question 18 says the change in position of a body is motion. And from to change from one position to another, that object is undergoing motion. The change in position of a body is called motion. So the change in position of an object in the body is called motion. So 19, it said the property of a body to remain at rest or in uniform motion with constant velocity is called inertia. Inertia is also taken from Newton's first law of motion that says everybody will remain at rest or in uniform motion except it's acted upon by an external force. So the inertia is the answer, is the ability of a body or the tendency of a body to remain at rest or in uniform motion. So the answer to that question is A. So what is the unit of force? It's in Newton. That's the SI unit of force. Remember the one we did earlier as question 1, we call it dyne. Why? That one is measured in gram centimeter per meter square. But when you come to the basic SI unit, the unit of force here is Newton, not dyne. That is to say, we are measuring in kilogram meter per second square. 1 kilogram meter per second square is simply 1 Newton. So the value or the solution to that question is Newton, which is option B. Say a force which tends to oppose motion is called frictional force or drag force. In a plane surface, it's called frictional force. But when it comes to fluid, whether air or liquid, we call it viscous force or drag force. But when it comes to a plane surface, it's referred to as a frictional force. So they can also ask you, the force which tends to oppose motion in fluid, is that case, it's called viscous force or a drag force. But when it comes to a plane surface, it's referred to as a frictional force. Then question 22 said a body of mass 5 kilogram moves with a velocity of 5 meters per second for 5 seconds. What force has the body applied? So what force has the body applied? So let's see how we can fix that. They gave us a mass of 5 kilogram. They gave us a mass of 5 kilogram. They gave us a velocity of 5 meters per second. They gave us time of 5 seconds. As you know, force, we said earlier, force is simply ma. So they gave us mass as 5 kilogram. They gave us velocity as 5 meters per second. They gave us time as 5 seconds. These are the data we have. So if you look at the data now, we don't have acceleration here. This is what we have. We don't have mass, velocity, and time. So how do we get our acceleration? Now, before the body start moving, this is the body now. Before it start moving, the body was at rest. That means the initial velocity of this body is 0. Before it start moving with a velocity of 5, that means the body was at rest. Initial velocity is 0. So initial velocity is 0. I will apply first equation of motion that says V equals to U plus AT. So if I make A the Sawyer formula, what are we having? V minus U is equals to AT. So my A is now what? V minus U over T. So with this expression, I can get my acceleration by fixing in my values. Velocity is 5, initial velocity is 0, the time is 5. So we're having 5 over 5. So our A will give us 1 meter per second square. So with that, I can now find the force. We say force is ma. So the force now will give us 5 times 1, which is simply 5 Newton. So that is the answer to the question. The answer is 5 Newton, which happens to be option A. So number 23, say how many seconds are in a year? We know that a year has 365 days. A year has 365 days, and a day has A day has 24 hours. A day is 24 hours. So let's see how we convert a year to seconds. We know that 1 year is equivalent to what? 365 days. That's the value of a year. And a day, 1 day, is simply what? 24 hours. 1 day is 24 hours. So if I multiply here now, in place of a day now, I'm going to have 1 year is simply 365 times 24. So how many hours? 365 times 24 hours. So a year is how many hours? 365 times 24, that will give us 8,760 hours. 1 year is 8,760 hours. But we're not looking for the year in hour, we are looking for it in seconds. What is 1 hour? 1 hour we know is 3,600 seconds. So if I multiply this value by 3,600, I'm going to have 1 year as 8,760 times 3,600 seconds. So what would that give to us? That will give us 315,536,000 seconds. So this is the value of a year in seconds. So let's see which of the options suits it. We have 315,536,000, which is option B. So the value of a year in seconds is that. So question 24, quantities that has magnitude and direction are called vector quantities. In fact, we have two basic quantities, vector and scalar. The one that have magnitude and direction, we call them vector, while the one that has magnitude but no direction, we refer to them as scalar quantities. So the answer to this question is B, vector quantities. So this is all we can take for today. Maybe tomorrow or another time we can fix another class, probably tomorrow, if time allowed. But this is what we can take for today. If you have any question, you are free to ask. Any questions? So in absence of no questions, we could end the class. Then we could fix another time for another class. So thank you for the time. And like I said earlier, if you are not subscribed to our channel, please help us to do so. STEMupAfrica. Then you can also send us your phone numbers in case of we have another class to fix. You can send the message directly.